Hey guys, Mr. P here, and today we're going to talk about factoring complex trinomials. Alright, complex trinomials, we're still dealing with three terms, right? Hence the trinomial, right? We got our one, our two, our three terms. In similar order to before, right? We have an x squared and then an x or a c. Usually it's an x as our variable, but this time on our x squared term, the a value, the coefficient in front of that is no longer a 1. Right? If it was a 1, it's a simple trinomial. But today, complex trinomial is going to be something that's not 1. It could be -1, it could be +2, something that's not 1. So that's how we know we're dealing with a complex trinomial. Okay, so we're going to go ahead and factor this complex trinomial. 6m squared plus 13m minus 5. Okay, and here are the rules to factor this thing. So first, we need two numbers that add to the middle coefficient. That's similar to simple trinomials, right? So we need to add to 13. And this time we're not multiplying to the -5 at the end. We're actually going to multiply to whatever 6 times -5 is, right? We take the coefficient off the first term and the full final constant, and we multiply them together. So 6 multiplied by -5, we get -30. So we actually want to multiply to -30 this time. Okay, so let's do that. Let's list our factors of -30 to see if we can come up with the magic numbers we need. So factors of -30. And we need to find the ones that add to +13, right? So we can do -1 and 30. That won't add correctly. We can do +1 and -30. Also not good. We can do -2 and +15. And that actually adds to the +13 that we want, right? We could keep listing factors, but once we find the one that works, stop there. Why go extra there? All right, so -2 plus 15 does add to the 13 that we want. So those are going to be our magic numbers this time. However, we can't just go right to our final answer. We have to do something a little bit different here. Okay, so what we're going to do, we're going to write the first term, so 6m squared, and I'm going to write the last term at the end. And those two numbers we came up with, we're going to put in the middle. So we got a -2 and a +15, except what we have to do to these middle numbers is we have to add the variable from the question to those numbers as well, right? So the variable is m, so we're going to add an m to each of those. The reason is because we're kind of rewriting this 13m as a -2m and a 15m. We're kind of breaking it up, so it's still an m, okay? So that was step one. Find the two numbers, fill it in, and we're not quite done yet. Next thing, I want you to kind of imaginarily slice this right after the second term, okay? And what we're going to do, we're going to common factor both sides, okay? So now we're going to common factor both sides of this 4-term system here. So on the left here, 6m squared minus 2m, looks like we can take out a 2, and we can also take out 1m. And when we divide the original pieces by 2m, to see our leftovers, first one, 6 divided by 2 is 3. And then m squared divided by m, we can cancel 1 to m, so we're left with 1m still. And then -2 divided by 2 is going to become -1. And then m divided by m is, again, 1. So it's going to end up being -1 in total there. Okay, so that was the left side. And same thing, we're going to common factor the right side on its own. So we have a +15m minus 5. So here we can take out a 5. Let's take out a +5. Let's do this a different color. Do not green, let's do red. We'll take out a +5. And then to find out what's left, if we divide the original terms by 5, we will get our remainder there. So 15m divided by 5, that's going to be 3m. And then -5 divided by 5, of course, is going to be -1. And you'll notice something, after you did that step, these two brackets are identical, which means we can literally common factor those out of this 4-term system here. So we can take out a full 3m minus 1. And what's left when we do that are going to be the 2m and the plus 5, which are going to combine to create our second bracket. Okay, and this right here is our final answer for this one. Okay, so 3m minus 1, 2m plus 5. Those are our two factored answer here. Okay, so a couple more steps than simple trinomial, but I wouldn't really call it complex. Okay, let's do another one here. Factor 3x squared plus 7xy plus 2y squared. So this one is definitely a complex trinomial, right? We have a term in front of the x squared that is not a 1, but we also have that double variable thing going on here. Okay, so here we're going to treat x as a variable, and the middle term, if it helps, let's rewrite the whole thing. Sometimes I rewrite out the middle terms and just flip the order of the variables. So I'll go 7yx plus 2y squared. That way it's easier to see that x is the variable there. Okay, so we need two numbers to add to 7y. I want to add to 7y. And we're going to multiply to the coefficient of the first term, which is 3, multiplied by the full last term, right? So yes, that last term has a variable in it, but it's kind of acting like our number from before. So we're going to do 3 times 2y squared, and that's going to give us 6y squared. Okay, so now we need two numbers that add to 7y and multiply to 6y squared. All right, so let's list factors of that 6y squared. Let's get a different color here. Factors of 6y squared. So we can do y times 6y. We can do 2y times 3y. We could do negative y times negative 6y. We can do negative 2y times negative 3y. Do any of these add to plus 7y? Yes, looks like the first one does actually. So I didn't even need those other ones. So y and 6y are going to be our two magic numbers here. Okay, and remember, once you get those numbers for complex trinomials, you're not done just yet. We have to fill in our middle term with those. Okay, so I'm going to rewrite my first and last term as is. 3x squared, and then we got a plus 2y squared. And in the middle, remember, the variable is x, and y is part of the number. So technically, we're adding in a plus y with an x attached to it, because that's the variable. And our other magic number is a 6y, so plus 6y, also with an x attached to it. Okay? So now we have our four terms there. Now we slice this in half imaginarily, and we common factor both sides on their own. So on the left, looks like out of a 3x squared plus a yx, we can take out really only one x. That's all we can take out. So if we take out an x from here and x from here and divide these to get our remainder, we can cancel one x here, which we're left with 3x. And on the right, cancel the x's, we're left with plus y. That's all we can really do. And on the right side, we can take from a 6yx plus 2y squared, we can take out a 2, so plus 2, because it's positive. We can take out 1y, and that is also all we can do on that side. So if we're correct, our right bracket should be exactly the same as 3x plus y. Let's just check those. So if we do this divided by 2y, this divided by 2y, we can cancel out the y's. 6 divided by 2 is 3, and then x. So far, so good. And on the right, cancel out the 2's, cancel out one of the y's, we're left with plus y. Perfect. All right, so now we're almost done. So those brackets are the same, 3x plus y, 3x plus y. So now we can common factor those out. Let's do this in red. We go with 3x plus y, and the remainders, the x and the 2y, if you divide both of those terms by the 3x plus y's, those are going to cancel, leaving you with basically the x plus 2y there, which is our factored answer here. Okay, again, complex trinomial, not complex, a couple more steps in simple trinomial, but definitely not complex. Let's do one more example here. Factor 2x to the power 4 plus 3x squared plus 1. So this one's a little bit different. The variable that we're dealing with here is not x, it's actually x squared. Because whatever variable's really on the middle is kind of the variable we're really using, so x squared. So we can think of our first term here as x4 really as an x squared that's squared, right? So we're going to treat the x squared as a variable, okay? So let's do this one. So that means we need two numbers that add to the middle coefficient. That's normal. We're going to add to positive 3. And we're going to multiply to the first coefficient, the 2, multiplied by the last constant there, the 1. So 2 times 1 is a tough one. You get 2. So that means we need two numbers that multiply to 2. And you guys probably know this one already. Add to 3, multiply to 2. So factors of 2, if you are really stuck, basically you got 1 times 2 or negative 1 times negative 2. So it looks like definitely that first one, 1 and 2, are going to add to the 3 that we want. So those are going to be our magic numbers, positive 1 and positive 2. So we're going to shove that into our middle term as x squareds. Okay, so we're going to write the first term as is, 2x to the 4, and then a plus 1, the last term at the very end. And in the middle, we want a plus 1 plus 2, so plus 1, and then a plus 2. And remember, the variable this time, it's not x, it's x squared. So we're going to add x squareds to each of these. So 2x squared and plus 1x squared, which we don't actually write the 1. So I'm just going to leave it as plus x squared. Okay, so that's what we have now. 2x to the 4 plus x squared plus 2x squared plus 1. So now we want to slice this right after the second term. And we want to common factor both sides separately on their own. So on the left, we can't take out any numbers, but we can take out two x's. So let's take out an x squared. And when we divide these by x squared to get our remainder, the 2 will stay, but we can cancel two x's with two x's, so we get x squared. And the second term, we basically cancel x squared with x squared, which gives us 1, right? The same thing divided by the same thing is always 1. And what do you know? This looks exactly like what's left here. So to get that in our bracket, we have to take out a common factor of 1, right? There's nothing else that'll be a GCF from 2x squared plus 1. So in this case, we have to take out a plus 1. And if we take out a plus 1, and if you divide everything by 1, it ends up being exactly the same as is, right? So that means there's going to be a 2x squared plus 1 in our bracket, which is what we wanted because we want it to be exactly the same as the bracket on the left there, the other factor there. Okay, so last step, we can take out those brackets. We factor it out, 2x squared plus 1. And once you do that and divide by the original terms, the 2x squared plus 1s will cancel, leaving us with the x squared plus 1, which creates our final factor, our final bracket there. So this is our final factored answer here. 2x squared plus 1, x squared plus 1. And one more scenario I want to talk about. So sometimes, just like in every type of factoring, sometimes you need to remove a common factor first, and then you can factor it as a simple trinomial. So the first one here, 20a squared minus 8a minus 12, it looks like you can take out a 4, divide a 4 out from all these terms. So you can go ahead and complex trinomial factor it right as is, but when you do 20 times 12, you're going to get some monster numbers that you probably don't want to deal with. So to make your life easier, common factor out a term first if you can. So we can take out a 4. If you divide everything by 4, you'll be left with 5a squared minus 2a minus 3. So now what you would do, now you would just go ahead and complex factor 5a squared minus 2a minus 3, and just make sure that you have that 4 on the outside of your final answer there. Okay, so you guys know how to do that. I'm gonna let you do that on your own. And the last one here, 3a cubed minus 7a squared plus 2a, we can't actually common factor out any of the numbers there, but if you look at the exponents, the a's, there's too many a's there. So what we can do, since there's at least one a in every term, we can actually factor out an a. And if you divide these all by a, you're basically canceling one a with the one on the bottom. So we're going to now get 3a squared. If you cancel out a here, you get minus 7a. And the last one, you get just plus 2 now, which is good. So now, in this bracket, 3a squared minus 7a plus 2 is a complex trinomial that we can now factor if we're going to continue with this. Okay, so that is complex factoring, guys.